Hello everyone, I hope you all are doing fine. So today in this lecture series we will be starting with the chapter vectors. Now this chapter is a portion of the unit known as vectors and 3D, and this is considered to be an important unit because you will see that from this unit there is always at least one question in each and every paper. It may either come from vectors portion or the second part of this, which is our 3D geometry. And also regarding vectors, you must have done a little bit of vectors while studying your physics as well. You must have done it in kinematics and understood what are the main basic concepts of vectors. So that those are the same things that are going to be used here, just a bit in a deeper concept. So let's start. So first, let's look at what are the subtopics that we are going to be covering in this chapter. First, we'll look at a brief introduction of what scalars and vectors are. Then we will be looking at the types of vectors, their position, addition, then dot product and cross product. These two topics are the most important topics of this chapter, dot product and cross product. Then we'll be looking at the graphical representation of a projection of any one vector on the other. Then we will be looking at a few more other topics, which is angle bisector and triple product. Now triple product, you must be thinking this is not in our syllabus. Then why are we still studying it? The reason being, of course, we do not know about JEE. JEE might use a few concepts of triple product in any one of its questions. So it is better that we look into a few initial or basic concepts of triple product and just the formula, so that whenever if there are questions that arise from this type of topic, we would be able to solve it. So let's start. There are of course two types of quantities. One is scalar and the other one is vector. We know scalar quantity is the quantity which has only magnitude, or it has the amount, and vector quantity is a quantity which measures both the magnitude as well as the direction. So for example, the most famous example for a scalar quantity and vector quantity are speed for scalar and velocity for vector. You must have studied this in your physics as well. Speed does not involve any direction in it. It is just a number, the amount. It represents the distance that any object travels in certain period of time. However, velocity, it also represents the distance traveled in certain period of time. However, it also represents the direction in which it is traveling. So that is why it is a vector quantity. Now if I was to talk about the representation of a scalar quantity, it is either represented simply by the variable, or when we write down its vector, it is represented in this way, a vector modulus, and vector quantity is simply represented as a vector. And this is basically, this diagram shows here how exactly a vector looks like, or in graphical representation how it might look like. So this portion here, this which is the tail end, and this is our head. This head is also known as the final point, and our tail end is also known as the initial point. Let us represent this for the time being with A and the head point with B. So how can we represent this entire vector? This can be represented as AB vector. And the angle that this makes with the horizontal, let's say it is theta, and this theta is what represents our direction for the entire vector. Now talking about the magnitude, how can we represent the magnitude? Magnitude is represented by, again, since magnitude is a scalar quantity, so it will be represented by AB vector mod, or simply we can write it down as AB. However, this one is most widely used, so it is recommended that you remember this one. Now what is our magnitude for this vector? It is basically the distance from point A to point B. So that is our magnitude, and this is how a vector is represented. Now we will be looking into the different types of vector that exist.